Hello dear students, welcome you all. Students, in today's lecture, we are going to discuss TdS equations. Right. We are going to drive TdS. It means we are going to drive some equations that will give us the value of TdS. These equations are called TdS equations. These equations are basically used in solving various numerical problems, right? So that's why they are important. So to drive these TdS equations, we will start with the first TdS equation. So it is now first TdS equation. For it, let's consider entropy S as a function of temperature and volume. Clear? So when I take the total derivative, ds is equal to curly S upon curly T be constant dt. Clear? Plus curly S upon curly V temperature constant dB. Clear? So that this is what I got when I took the total derivative of this equation. Then multiplying both side by t. So it will become TdS is equal to T curly S upon curly T constant volume dt plus T curly S upon curly V constant temperature dB. Clear? Let this is equation number 2 and it was equation number 1. Clear? Now we know very well that this T curly S upon curly T B is equal to CV, specific heat at a constant volume, right? This is one thing that we are going to put here. Clear? The other thing is, according to Maxwell's second equation, according to Maxwell's second equation, we know curly S upon curly B T is equal to curly P upon curly T B. Clear? This is Maxwell's second equation and this is equation number 3. So now I'm going to put this here and this here. So then after I will get TdS is equal to CV dt plus T curly P upon curly T constant volume or a dV. This is equation number 4. Clear? Now this equation is called first TdS equation. Clear? This equation is called first TdS equation. This gives us the value of TdS. Clear? In terms of specific heat at constant volume and temperature, change in temperature, curly P upon curly T, all these terms here, right? So this is first TdS equation. Clear? Now we are going to drive the second TdS equation. So now we are considering entropy as a function of temperature and pressure. Clear? This is another way we can take the entropy as a function of other variables, temperature and pressure. Earlier we have took entropy as a function of temperature and volume. Clear? So now we are taking it as a temperature and pressure. So again the same thing, we are going to do the total derivative. ds is equal to curly S upon curly T constant pressure dt plus curly S upon curly P constant temperature dP. Clear? Again multiplied by TdS on both the sides. Sorry, T. Then I got TdS is equal to T curly S upon curly T constant pressure dt plus T curly S upon curly P T and dP. Clear? Now curly S upon curly T P, right? And T multiplied by T. So this is what? This is Cp, specific heat at a constant pressure. Clear? So I am going to put Cp in place of this term in this equation. That this is equation number 5. Another thing that we are going to use here is Maxwell's fourth relation. Sorry, Maxwell fourth relation is according to Maxwell's fourth relation, right? We have curly S upon curly P T that is equal to minus curly B upon curly T at constant pressure. Clear? So I'm going to use this value here. Clear? And this value here. So then after making these substitutions, I will get TdS is equal to Cp dt in the first term minus T curly B upon curly T, right? P and dP. You can see here the same thing. Clear? But only thing that I did is I replaced this with this term. Now this is equation number 6, and this is called second TdS equation. Clear? This is second TdS equation. Clear? This equation is a second TdS equation. Clear? So this equation gives us the value of TdS in terms of Cp and curly V upon curly T, and change in pressure and change in temperature, right? So in certain numerical problems or certain situations in the thermodynamics, we use this equation. Clear? Depending upon the problem, uh, we can use this equation also if the problem is of this type, right? Now I'm going for the third. Clear? Right? So for driving the third TdS equation, we will take entropy as a function of pressure and volume. Yeah? So now the situation is different. In the first one, you can see here, we took entropy as a function of temperature and volume. Then we took temperature and pressure. And now we are taking the third combination, pressure and volume. Clear? So again, taking the total derivative, ds is equal to curly s upon curly p b dp plus curly s upon curly b constant pressure dB. Clear? Then multiplying by t on both the sides, then it becomes t curly s upon curly p b dp plus t curly s upon curly p p d b. Clear? That this is equation number 7. Clear? Now we can simplify this equation further by making some substitutions. Now, you can see in this equation number 7. Now, we can't make substitutions as we did in the earlier case here and here, because these equations, these two terms are not linked with any term. So we have to convert these terms in another terms, right? So for it, I can write curly s upon curly p b is equal to curly s upon curly t b into curly t upon curly p b. Clear? I can do it. Similarly, for the second term, that is curly s upon curly b p, I can also convert it into curly s upon curly t b, not b, sorry, it is p. Now it is pressure into curly t upon curly b pressure. Clear? So now this is equation number 8, this is equation number 9. Now I'm going to put this value here and this value here. Clear? So when you will put these values, you will get TdS is equal to T into curly S upon curly T B into curly T upon curly P B dP plus T curly S upon curly T P into curly T upon curly B P dV. It is equation number 10. Clear? Now, you can see here that this term T curly S upon curly TB, it is equal to CB, specific heat at constant volume. Similarly, T curly S upon curly T at constant pressure is equal to Cp, specific heat at a constant pressure. So I am going to make these substitutions in equation number 10. So then I will get TdS is equal to Cv curly T upon curly P volume dP plus Cp curly T upon curly B constant pressure dV. So now this equation number 11, it is the third TdS equation. Clear? This equation is third TdS equation. Clear? Third TdS equation. Right. So now we have derived all the three TdS equations. This was the first one. Clear? Right? We derived it by considering S as a function of temperature and volume. This was the first equation derivation. Uh, then we derived the second one by considering S as a function of temperature and pressure. This is the second equation. Similarly, we derived the third one by considering S entropy as a function of pressure and volume. Clear? Same approach is followed in all three cases, and then we got this equation. So all these equations give us the value of TdS that I told you in the beginning. TdS. Clear? So depending upon the numerical problem or problem of thermodynamics, we can utilize this relation for solving that problem. Clear? It linked TdS with different changes, different variables, specific heat, and all these things. right? So these three equations are very important from the perspective of numerical problems, right? So thank you very much